Okay, so today we have a new question, which is a median question, and although it's 583, it's a little bit over 400, number 400, but there is almost 2,000 upvote for this question. So I think it's a good question, and then, but I don't know if I have what it takes to solve this problem. So come on, let's try it. Okay, so it's number 583, and let's read the question first. So um, the question is delete operation for two strings. Given two strings word1 and word2, return the minimum number of steps required to make word1 and word2 the same. In one step, you can delete exactly one character in either of the string. Okay, so for the first example, we have C and ED, and the minimum step is 2. So you need one step to make C to EA, and another step to make EAT to EA. Okay. And then example 2 is word 1 LeetCode, word 2 etco. So it took ETCO. So you have the same string in here. So you delete 4 from the word 1. So from the example, we know that word 1 and word 2 could be in different length, right? And then number 2 is we want to make word 1 and word 2 the same by each time deleting one character from either string. So you will end up having a what is called subsequence, not a substring, not a subarray, but subsequence. I guess on all of those LeetCode questions, there is some concept that confuse me. So if they are talking about subarray, means that consecutive uh, consecutive element of that array or string. For example, this will be a substring or a subarray, and this could be a subsequence. But usually what they call a subsequence is that you just randomly take something and then combine it together to make another new string. So for LeetCode, a subsequence could be ETCO, and it could also be LEDE. So I think for this question, it looks like we are making a subsequence, right? Because we can delete one character from either of the string anytime we want. And what's left, although it's a string, but it compared to the original string, it's actually a subsequence of that string. And I hate that there's no hint. So the length of word 1 and word 2 will be limited by 500, and then they consist only lowercase, so we don't need to worry about the case of the letter. So can we so usually, I don't know, for the minimum something, I would think about BFS. So I could possibly doing a two-way BFS from word 1 and word 2, and until they're, for example, then for LeetCode, this word, the next level in BFS is to delete one character, right? So it will be like EETCODE or LETCODE or LE, oh, that's the same, LEETODE. So you find your next neighbor and put it into the next level, and until the both BFF overlap with the same string, then you find the minimum. However, that probably work if war1 and war2 are the same length, but for war1 and war2 on a different length, it will still work, right? So you count how many level to reduce war1 to 4 characters. That could work. And then when they both are the same size, then you start doing BFS for both sides. But it looks like a lot of memory though. If war1 is 500, right? And then to delete one of the character, we then will have 500 combination, and then each of them will then generate 499. So I will get memory limit exceed error for this. So if I am doing, so for a word length 500, I can definitely not doing BFS because I don't have that many space. Yeah. Okay, then if it is so how about DFS? Like DFS every round we delete one of the character. We choose one from the two and delete one, and we go to the next one. Yeah, so BFS, you can use a set to memorize those that you already add to the queue. So for DFS, you then use a memo to remember those same recursive call that you already calculated, right? Okay. So what's the time and what's the space though? If using DFS and memo, then you will make it's manageable, I think, because one word is 500 length. So added together it's 1,000 length, and you will at most make 1,000 recursive call, I think, right? Because you have memo, so each no, it's 500 times 500. Yeah, it's 500 times, but then it's still manageable, I think. Okay, remember there is one question on LeetCode that is the longest common subsequence, LCS, right? So this is essentially finding the longest common sequence on the, okay, I'm gonna Google it. LeetCode and longest common subsequence. Yes. I'm cheating, but there's no hint. Although it's a medium question, but there's no hint. Okay, so this is also a median, right? So that's 1143. And then for the longest common sequence is we have 2 string and the length is 3 because you got ACE in both, right? And then you remove ACE. You remove B and D. Okay, so is that the same? Almost the same. So this is the length of the longest common sequence. But this is the step to reach to the longest common sequence, right? So how, but this looks so similar though. And there's no hint still. Shoot. Okay. Oh, so DFS is essentially, well, DFS and Memo is essentially dynamic programming, and it's top-down dynamic programming. But for this, the LCS questions, I remember there should be a bottom-up dynamic programming solution that we have an array, a 2-dimensional array by the length times the length, length of the text 1 times length of the text 2, and then each, okay, let me try to, so if we would to do DP, and especially it's from bottom up, we would have a DP like and which is the word length of those two. I know I did this before. I can't remember how to do it. And then the meaning of each element in the array means that, for example, if we have like DP, for example, 1 and 2, means that the answer for the first string stop in here, number 1, and the string 2 stop in here, right? So if we have a solution for SE and EAT, if we got the solution, then how do we get the solution for SEA and EAT, which will be the solution, which is the minimum step to reach to this point. I'm confused, right? I'm confused. So if we have a solution for this already, how do we reach this? This is the solution of this plus 1. Is that so? Plus 1 if I have no idea. If this is the dynamic programming, I have no idea. I remember there should be a button up. So can I do just simple top down? But I don't know how to do the top down though. So for the top down, we pass this SEA and EAT, and then okay, let's try top down. Otherwise, I'm going to see the solution. Because this I have no idea how to do it. I really don't have any idea. So if I use top down, I will want to do a memo. I will name it memo. Right. Let's do DFS. I really don't know how to do it. There's no hint, so I'm ready to see the solution. So if we would do a top down, so let's forget about this first. I'm probably not going to do this. So let's define the top down first. So I will return like a DFS of the string 1 and string 2, right? Or I don't need to call another one. I will just use the same minimum distance. May I? If I do a global, then I don't need to declare, right? So if I do a map of string to integer map equals a new let's call it memo. Hash map. So if we do this, then when we call this, okay, I will try the DFS with memo. If I got it wrong, I will see the solution, because other than this, I have no idea how to do it. So I will do the word one then equals to null or word one dot length equals to 0. And this. So we check if both are null or 0. This is our first ending condition. We return 0. Our second ending condition is if one of them are 0. I return word 2 dot length. And I will do the same. Oh, I have a bad feeling that I won't be able to solve this. It's a medium, but if it's a DP, then I don't think I can do it. Word. 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 Okay, so this is our ending condition for our recursive DFS call. Now, if we reach to this point, we know that both of them are not 0, right? So we would wow, I think my solution might be way wrong, but let me do it. So what I'm going to do is now I will delete one of the character and then recursively call do we have other ending condition? I mean if the two if the two word are different length, do we only need to deal with the longer one or we deal for both? I think we deal for both. So that case, I am going to delete every one of them, every character of them, and then recursive call the next level. Is that too much? I am going to get a memory exceed error. Oh my god. So for inti equals to 0 I word 1 length. So I am going to, so this is for word 1. So I'm going to get a substring, remove the 0 to the less. Hello. So, and then recursively calling it, I think. So let's call the DFS, like not DFS, let's call this let's call this. And how do we get the substring? So we have the substring of this from 0 okay, so how do we remove the okay, it's from 0 to I plus oh my goodness, I have the word 1. I'm trying to get started on LeetCode. Any recommendation on where to start? I have been doing LeetCode for way too long, and I don't know if I start from easy. So I start doing like the easy question within the 400 range, and then get a hand of it, and then build my confidence of doing this, and then I start doing the medium. So I think the first 400 question is the most important of them, and you can start with the easiest one. And if you but if you like me, who don't remember anything about, or before I start doing this I don't know Java, so I actually read some Java coding book, and then I also took the Coursera course. What's that called? One of the Coursera courses is called Algorithm 1 and 2 by Princeton, I think, at Princeton University. Yeah. Or you can I don't remember the name of the book, but there was a book like coding interview something. I forgot. Or you can read that book. Yeah. But I actually just start doing the easy question within the 400 range, and then yeah, try to get myself familiar with coding. I+1. Yeah, so I if I check my own record, I have tons of easy questions that if I redo it again now, I would do it differently. But during that time, way back then, I like even the easy question I cannot solve it with the yeah. So I and also I pay for the I pay for the premium, but you can start doing the free ones. And I forgot, if you don't pay, we will be able to see the solution. So my trick is that if within 15 minutes I won't be able to solve it, I will directly check the solution or check the discussion forum, see the solution by others, and then try to mimic it and see if I can code it myself. Okay, so the substring from this to the end, and then we do word 2. Oh my god, I really don't know if that's correct. So I mean, I probably need a minima equals to like word1.length. I can't type, so let me plus this. So I have a minima, and then I will do the minima equals to math the mean of minima and this. Oh, it looks way too long. And this +1, I forgot to +1. Yeah, because we remove 1, right? And then we will do the same thing. I totally don't think this is the correct solution. We will do the same thing for word 2. So for word 2, did I call it correctly? So for word 2, let's do this. Word 2, 1. And then this is word 2. This is word 2 +1. And then we return the mean. So this is DFS without memo, right? But I don't even think this is correct. So, okay, so this is my ending condition. I first have a mean, which is the length of the 2, because that's the maximum we can get. And then for each one, we remove 1 and then recursively call it. And then, and then we do the mean and give it to mean. And then for word 2, we do the same. And then, okay, so this is without the memo. So now let's do the memo. So after our ending condition, we will check if let me do it this way. So I will have a string key equals to word1 plus a comma plus word2, and then if the memo contains key, then we directly return memo.get key. And then before we return, we also memo.put key min. I don't think it works, but I would like to try. That's ridiculous. I always have compile error. Return. Yeah, it doesn't work. So why it doesn't work? Why? Your expect answer is 2. So let's see. So for this, you need to remove S. You need to remove T. Okay, thank you, space after return. I now see that. Okay. So what's wrong with this? What's wrong with this? So theoretically, we have removed the first one and then call EA, and then remove the second one and call SA with EAT, and then we remove the third one. Oh, hold on. If they are the same, I mean, my ending condition should include like, okay, I still don't know if this is correct, right? So if word1 dot equal equals word 2. So if they are the same, we also stop, right? Is that why? That is why. Okay, finger crossed. I'm going to submit because I don't have any other idea how to do it. I don't know if this will be time TLE, time limit exceed, or memory exceed. I have no idea. What? Why this got crossed out? Oh no, I have the plug-in. Okay, God. Okay, I am. So hold on. So what's the time complexity? Because I am at the most calling the recursive call once for each character, right? I think. So it should be, the time complexity should be word1 plus word2. No, word1 times word2, right? Yeah, because I have each different combination once. Yeah, word1 times word2. So it will be O, or let me say, time is O W1 plus W2. So it looks okay. I shouldn't get time TLE. What's the space? The space is the map plus the stack. The system stack when we call it recursively. So the map size will be still this, right? Ah, shoot. And then the stack size. Now the problem is, what's the stack size? Oh, it's wrong. I think the stack size is the same. Because the deepest you can call is to remove both, right? So to remove the deepest level you can call is you remove one from wall 1 and call it again, one from wall 1 and call it again until wall 1 is empty, and then you remove wall 2, one from wall 2, and then until, so the space should be this plus this times plus which will be shadowed, this one will be shadowed by this. So it means that the space complexity is still this. Not too bad. So it should pass. You should pass. Submit. No, it's bad. Okay. Yeah. So it looks like I will need to see the solution because there should be a bottom up DP which will pass this. Yeah. And this is not a long sentence, long word. I should at least try it. I should try it. I mean, that's so obvious that, okay. So if I cannot come up with the bottom up idea, I am going to see the solution. Okay, let's cheat and read the solution. So this is number, right? It's 483, right? Yeah, it's 483. And it's a medium, but I can't. Using longest common sequence TLE, so is that me? Because that's my idea using this. So I got the wrong idea. With memorization, accept. Isn't this my idea? Okay, let's read the code. So they have a memo. Cool. And then returned the length plus the length minus 2 times, yeah, because the longest common sequence you need to is the length you need to remove, and you need to remove from both S1 and S2, so it's 2 times this. Okay, so okay, they apply DP with memorization on LCS, but for us, we apply the DFS with memorization directly on this. I guess that's the difference between mine and his, but I don't get why he's passed but mine is not. So let's see. So they have S1, S2, M is the length, N is the length, and then the memo. So if both are 0, return 0. If memo have the answer, return memo. And then if as the char at n-1, so if the last one is equal, oh yeah, that's my original idea, but I can't find a way to do it. So for the LCS, you compare the last character, right? So if the last character is the same, your memo, well, your answer will be the longest common sequence of 1 minus 1 and plus 1. 1 is the one that you got removed. So yeah, the idea is that if I have A, B, C, D, G, and I have Y, KPLG. So because the G is the same, so to remove this is length 1. So this is where the 1 comes from. And your LCS will be recursive calling for this too. Otherwise, if the last character is different, you either remove the one from the left or the one from the right. Okay, so it's similar. It's the similar idea, but I failed. I failed how? I failed because each one of this, each call of LCS, they at most recursive calling themselves twice. Compared to mine, I recursive calling them as many times as we could. Right? I run until this length, I run until this length, not to mention that the string concatenation is time consuming. But for this is way faster because the recursive call is only maximum of calling it twice. Okay. Let's see the third one, dynamic programming. So when they only say that it's dynamic programming, usually they mean it bottom up dynamic programming, which means that you have an array as the mammal, but instead of you do it from the last one, for the bottom up you do it from the first one. So both start with 0, and then if each one of them is 0, you continue. Why you continue? Because 0 is 0. Really? Zero is 0? Oh, I is length. I is length. So 0 length. If 0 length, I'm still so confused. Otherwise, if the last character is the same, your DP is 1 plus this. Otherwise, your DP is this. So it's the same idea as this. But you do it bottom up. Okay. And then you also have one without using LCS. So you have a DP. Oh, so this is our idea, but instead they change it to bottom up. So you directly memorize. So if either of them are 0, your Dij is I plus j. So this logic is what we have in here, this. But I wrote so long, and their logic is so clean. You just use I plus j because one of them will be 0. Smart. And then if you have these two the same, then this will be this. Do you not need to add 1? Oh, because they are the same, you don't need to delete anything. But if they are different, you need to delete 1, and then you got the minimum from. Oh my god. Okay. Wow, 1 dimension. Also, they now reduce this to 1 dimension. So this is essentially the same, but because each round you only use the previous round, so you don't need to keep the array of the entire history. you only need to memorize the previous round's answer. So instead of 2D, you can reduce it to 1D. So this is the same with that, but reuse this. Okay, but I'm still not sure if I can just directly modify my answer. And yeah, so if I can optimize this part, right? So let's see if we can just optimize. So let me copy this first. These are the ones that got me trouble. And how do we? So let's reduce this, right? So let's not do this too. Let's use the logic that if word one dot char at oh, I need a length. Word one dot length -1 equals to the same thing for the 2. So I guess this is the logic that I failed. If these two are the same, mean equals to recursive calling yourself so word one dot substring string substring from 0 to to this, and the same thing for word 2. Otherwise, mean equals to math dot mean you call this, oh, that's too long. So let's define, so we don't need to initialize this, I think. But I need a m equals to word, or no, let's do then 1 equals to word 1 dot length, and then 2 equals to word 2 dot length, because it was too long and I don't want to type, so I have this as length 1, this as length 2, and I have the then 1 minus 1, then 2 minus 1. Otherwise, your recursive call will be method minimum. It's either this or this. and then you still put it in there. Yeah, so if I use their logic to reduce our code, oh, it's even worse. So what's wrong? I can't do the top down. So okay, I guess I just need to erase everything and redo it from scratch. But I am just curious why I use their logic and it's not working. So if the last one is the same, I recursively call the substring. If the last one is different, then is 1 plus. That should be it. Oh yes. And now we got this passed. So do we want to try like this and this? Run. Okay, I'm going to submit again, but let me remove those ugly code first. And then the time complexity is what? I'm curious, but let me submit the code first. But I don't think my analyze is now correct. Let's submit again. Okay, so the top-down memo still work if you apply the top-down directly to this. Yeah. So the key is you cannot recursively call yourself so many times. Yeah, so now what's the time complexity for this kind of algorithm though? So I guess my is the same as this approach, right? Memorization. So yeah, it's still m times n, n times n. So just like what we discussed a couple minutes ago, the time complexity and the space complexity is m times n. Yeah. Although I don't, because the depth of the recursion is max of n or m, and it's shadowed by this one if you use big O notation. Okay. Okay, that's for today. Today, although we cheated, but I believe I learned something. So the thing is, I blindly believe that the DFS plus memo can help me like resolve any issue that I need dynamic programming. The key is even you have the DFS with memo, you still need to guarantee that you won't recursive calling yourself so many times. Because the key of the top down, the difference between the top down and the bottom up is that the bottom up, when you declare a DP array, it will only calc one of them once. But when you do a memo and then calling DFS, you actually will call the same node, same DFS recursive function so many times. Although every time you call it, it directly returns the answer from memo, but you're still calling it, right? So you are still inputting everything on the student stack and then call the recursive function and then get the answer from the memo so many times. But if you're doing a bottom up, every cell you will only calculate once, and that's it. You won't visit that one ever again. So when you are able to do a bottom up, you should always do a bottom up. I mean, you should always start from the top down and then see if you have the ability to transfer it to bottom up. And because every time when you transfer it to a bottom up, you can then observe if your equation always only use the answer from the previous one, like I minus 1, not I minus 2, not I minus 3, always minus 1. If that's the case, then you can further reduce the space to one dimension, like here. So, lesson learned. Use the DFS plus memo as your last resort. Do a bottom up whenever you can. Okay, so although it's a million question, it took me almost an hour and cheated see the solution to do it. So hopefully tomorrow I can do it without cheating. So that's it for today, guys. So I will see you tomorrow on Saturday. Thank you for watching. Bye bye.